For decades, we've been obsessed with Mars. We've sent rovers, orbiters, and landers, all dreaming of turning the red planet into a second Earth. But what if we've been looking at the wrong world? While we've been focused on red dust, the scientific spotlight has started to shift to a stranger, more distant target, a moon of Jupiter that's bigger than the planet Mercury. This is a moon that generates its own magnetic field, a feat no other moon in our solar system can claim. And it's a world with a hidden ocean that might hold more water than all of Earth's seas combined. This is Ganymede, and it's quickly becoming the new frontier in our search for life beyond Earth. Welcome back, space explorers. Today, we're journeying over 600 million kilometers from home to the king of Jupiter's moons. If you've ever looked up and wondered if we're alone in the universe, Ganymede is one of the most compelling reasons to think the answer might be no. It's not just a frozen, silent ball of ice. It's a complex, dynamic world with a story told by its magnetic field and a massive secret hidden deep beneath its crust. So what's all the fuss about this giant moon? The first big clue, a wobbling ghost. Our story starts not with a spacecraft, but with a ghost. A ghostly light, to be exact. Like Earth, Ganymede has auroras, shimmering ribbons of gas that glow at its north and south poles. And back in 2015, scientists using the Hubble Space Telescope noticed something strange about them. They were wobbling, but not nearly as much as they should have been. You see, Ganymede is caught in a gravitational dance with Jupiter, and it's embedded within the planet's colossal magnetic field. As Jupiter rotates, its magnetic field shifts, and that should cause Ganymede's auroras to rock back and forth by about 6 degrees. But they didn't. Hubble's observations showed they were only moving by about 2 degrees. Something was pushing back, creating a kind of magnetic friction that resisted Jupiter's pull. This was a huge clue. Scientists concluded that the most likely explanation was a massive, global layer of electrically conductive fluid. In other words, a vast, salty ocean. This observation provided some of the best evidence yet for what had been suspected for decades. Ganymede has a subsurface ocean. And its scale is almost impossible to grasp. This ocean is estimated to be about 60 miles, or 100 kilometers, deep, 10 times deeper than any ocean on Earth, all buried under a crust of ice thought to be roughly 95 miles, or 150 kilometers, thick. The wobble in Ganymede's aurora was the fingerprint of a hidden water world. The ingredients for life, but just having an ocean isn't enough for life. You need the right kind of water and the right ingredients. This is where Ganymede's story gets even more exciting. This moon isn't just a simple sphere, it's a fully differentiated world, a lot like Earth. It has a liquid iron core, a rocky mantle, and then its massive ice and ocean shell. Why does that matter? It means Ganymede has a history of internal heat and geological activity. We can even see the evidence on its surface, which is a tale of two terrains: ancient, dark, heavily cratered regions, and younger, brighter, grooved landscapes. These grooves are vast networks of ridges and valleys that stretch for thousands of kilometers, likely formed by tectonic forces stretching and cracking the moon's icy crust over ages. But the most tantalizing clues came in 2021, when NASA's Juno spacecraft flew within just 650 miles of the surface. Its infrared spectrometer didn't just see ice, it saw the chemical fingerprints of salts. Specifically, data revealed hydrated sodium chloride, ammonium chloride, and sodium bicarbonate. Even more interesting, Juno may have also detected organic compounds, possibly aliphatic aldehydes. Organics are the carbon-based building blocks of life. Finding them on the surface, along with salts, suggests that briny, mineral-rich water from the ocean below may have reached the surface. These findings hint that Ganymede isn't just a world with water, it's a world with complex chemistry and some of the key ingredients needed to build life. If you're enjoying this journey into the secrets of Ganymede, do us a favor and hit that like button. And if you want to continue exploring the most fascinating worlds in our universe, make sure you subscribe and ring that bell. We have a lot more to cover, and you won't want to miss what's coming up. The race is already on, and this isn't just a far-off theory. The mission to unlock these secrets is already in flight. In April 2023, the European Space Agency launched the JUICE mission, which stands for Jupiter Icymoons Explorer. After a long, 8-year journey, JUICE is scheduled to arrive in the Jupiter system in 2031. While it will also study Europa and Callisto, Ganymede is its main event. Around December 2034, JUICE is scheduled to do something no spacecraft has ever done: enter orbit around another planet's moon. For almost a year, it will become Ganymede's personal satellite, mapping its surface, studying its thin oxygen atmosphere, and using radar to probe its icy crust. The mission's goals are clear: to characterize the ocean, understand the geology, and assess its potential to harbor life. Of course, the challenges are enormous. Ganymede is constantly bombarded by Jupiter's intense radiation. While its own magnetic field offers some protection, especially around the equator where Juno found the highest concentration of salts and organics, the environment is still incredibly harsh. And then there's that ice crust. Actually reaching the ocean would mean drilling through an estimated 100 miles of solid ice, a technological leap that is far beyond what we can do today. But the scientific prize is so huge that these are seen as the next great engineering hurdles to overcome, not stop signs. The data from JUICE and Juno will pave the way for a future where a lander, and maybe one day a drill, could touch down on this icy giant. The Goldilocks moon of Jupiter? For years, another of Jupiter's moons, Europa, has been the star of the show in the search for life. Its ice crust is much thinner, which makes its ocean seem easier to get to. So why the pivot to Ganymede? You could almost think of Ganymede as the Goldilocks moon of the Jupiter system. Europa's ocean is in direct contact with its rocky mantle, a big plus for habitability because it allows for chemical exchange and potential hydrothermal vents. But Europa is closer to Jupiter and gets blasted by much more intense radiation. Farther out, the moon Callisto is less irradiated, but it's also less geologically active, and its ocean might be cut off from its rocky mantle by a layer of ice. Ganymede seems to sit in a sweet spot. It's far enough from Jupiter to avoid the worst of the radiation, and its personal magnetic field provides an extra shield. Its massive size has allowed it to retain internal heat for billions of years, driving the geological activity we see on the surface. The combination of a relatively stable environment, a vast ocean, a protective magnetic field, and the detection of salts and organic compounds makes Ganymede a uniquely compelling place to look for life. It might not be the easiest place to check, but it just might be the best. Our role in the discovery. What's cool is that this story is unfolding right now. The data from Juno's flyby is still being analyzed, with new discoveries being published. And you can follow the journey of the JUICE mission as it makes its way across the solar system, preparing for its historic arrival. More importantly, Ganymede forces us to think bigger. For centuries, our search for life has been based on what we see here on Earth: rocky planets, in the habitable zone of a star, with liquid water on the surface. Ganymede shatters that idea. It suggests that the most common habitats in the universe might not be worlds like ours, but rather the hidden oceans of icy moons orbiting giant planets. If we were to find life in Ganymede's deep, dark ocean, it would fundamentally change our understanding of our place in the cosmos. It would suggest that life isn't a fluke confined to sunlit surfaces, but a resilient force that can pop up in the most extreme and unexpected places. This is more than a science mission, it's a quest to answer one of our oldest questions. So, why are we racing to Ganymede? Because it's a world of superlatives and secrets. It's the largest moon in our solar system, bigger than a planet. It's the only moon with its own magnetic shield. It has a hidden ocean that could hold more water than all of Earth's oceans combined, and we've already found tantalizing hints of salts and the chemical building blocks of life on its surface. For all these reasons, Ganymede has transformed from a distant point of light into one of the most important destinations in our solar system. This isn't a race to plant a flag, it's a race for discovery, for knowledge, and for a chance to find out if we are alone. So, what do you think? Could life, in some strange and wonderful form, be thriving in the dark, briny depths of Ganymede's ocean? Let me know your thoughts in the comments below. And if you want to stay updated on the latest discoveries from the frontiers of space, make sure you subscribe and join our community of explorers. Thanks for watching, and keep looking up.